This video, right, we actually talk about what if the real locus cross the real axis. So imagine we have a system over here, and then what if it cross over this real axis, right? So we're trying to find this point over here. We're trying to find the value. Okay, what is this value? This real value, and then also to find what's the frequency. In order to find the frequency, then we can find this real value. And we say that this is actually the omega. I mean, this is the lambda. Okay, so with this lambda, we can actually find our gain margin. And the higher the gain margin, the more stable we are. If you don't remember anything, if you don't ring a bell, you should go and rewatch the video. Okay. Okay. I think I should tell you lah. Okay, because if the gain margin is smaller, right? If this is smaller, you're further away from -1, right? If it's bigger, you're more nearer to -1, which is more unstable, right? Okay. At least you don't need to go and rewatch. So this is only when you have a real axis touching the real axis, right? So we actually solve for this. But now, what if we have a system that touches the imaginary axis? Okay, we want to find this point. How do we gonna find, right? What is this imaginary value, and what is the omega value? So this is the key thing typically you want to solve for a nyquist plot. Okay, the real and the imaginary value. So in this case, the approach is about the same, okay, as the previous one. So let me try off with the first thing, because actually it's not from the book anymore. Okay, it's not from this book anymore. So I'm on my own now. So hold on. So I have a transfer function. Okay, g of s is equals to 1 over s plus 1, s plus 2. Okay, so this will simulate this nyquist plot, where omega is equals to 0 to omega equals to infinity over this point over here. So from this point to this point, right? So we're trying to find this point, okay, the point that intersects the imaginary axis. Okay, so in order to do that, the first method is actually to say that we're actually moving in negative 180 degrees. Am I right? No. We are actually doing negative 90 degrees only. Why? Because we are only trying to find the frequency at this line only. This line compared to the origin is only 90 degrees, minus 90 degrees. If you were to do this, is the real axis is 180 degrees from the origin, right? So it's minus 180 degrees. So make sure you know, okay? Make sure you know what you are doing, okay? Because I still don't know what I'm doing, so I do wrong just now. Okay, so it's minus 90 degrees. And then now, I just put here minus 90 degrees. So therefore, you know that there is two poles. So two poles, you have a negative, right? One pole contributes negative phase, right? Tangent inverse. Okay, you know that j omega plus 1 and j omega plus 2, right? 1 divided by 1. So this is the after I sub in s equals to j omega over here, alright? So if I want to do a, if you remember, this is imaginary over the real, so it's opposite over adjacent, right? So if I were to do that, is minus then inverse tangent omega, and then oh yeah, one thing, okay, before I do that, can you see anything? Something is wrong. Something is a little wrong. Okay, actually not much of a wrong, okay, not much of a mistakes, but it'd be good if you were to do that. Okay, what I mean is that we say that we're trying to make this coefficient to be 1, right? Same as this. So what I can do is actually j omega plus 1, and then I factorize out the 2, so I have half j omega plus 1. Wouldn't it be somewhat easier? Okay, so with this said, this is omega. Okay, this is for the j omega plus 1. Okay, minus away tangent minus inverse omega. actually is half omega, right? This is for the 2 half j omega plus 1. Okay, just simply to do that so that it is easier for you to do, right? Because yeah, it should be easier, but you can also don't do that. This is a dilemma, okay? But make sure you know how I did that. Okay, I actually factorize out the 2. So 2, if you factorize out the 2, you divide everything by 2, right? So therefore 2 is out here, and then you divide by 2, you have half j omega plus 1, and then 2 is outside. Make sense? Make sense, okay? So let's continue, okay? Since we know that this is the thing, okay, minus 90 degrees is equals to minus tangent inverse omega minus tangent inverse half omega, okay? So we want to solve for this frequency, right? So hold on. So the next thing I need to do, okay, is actually to do the okay, to actually make them positive first. So I cancel away all the negative. So what I have is actually plus tangent inverse. So as you can see, this is the trigo rules already, right? I'm sorry. So this is the trigo rule already. So if you were to remember back our formula sheet, okay, our trigo rule formula sheet, you can see there's so many videos. Damn. Okay, actually I'm lagging. Okay. So important trigo rule. Okay, this is like a secret chest. What am I talking? Shit. Okay, so this is the trigo rule. Okay, for if it's a plus b, okay, you can use this formula. If it's a plus b plus c, right, you can. It's a long chunk. So as I said, you need to memorize. So in this case, we are this. So it's a plus b divided by 1 minus ab. So I just put this aside, and then I just follow s so that you can actually know what I'm writing actually also. Okay, I don't know. Okay, I think you can see. Okay, I'm not gonna do anything. So knowing that this is tangent inverse, so okay, I'll zoom in now. So tangent inverse a plus b. Okay, a plus b is actually omega plus half omega divided by 1 minus ab. So omega times half omega square. I mean half omega. Okay. So this is the equation. So after I apply this trigo rule, okay, this trigonometry rule, if you ask me what I get, I also don't know. But I just yeah. So just trust me lah, okay. If you get the answer, then you can trust me already, okay. So let's continue first. So after which we do that, okay, we have this value over here, right? And then 90 degrees. And in order to clear away this tangent sign, I actually introduce a tangent. Okay, so a tangent multiply with a tangent inverse. Okay, this thing is actually this one. I just lazy to write. So as you do that, you have tangent 90 is actually infinity. Okay, so if you were to clear away, you have omega plus half omega, which is 3 second omega, 1 minus half omega square. Okay, so as you can see, what makes the systems go infinity? You can see is this point over here, right? Whatever thing divided by 0 is equals to infinity. So previously if you're finding the real axis, right, you're finding the whatever thing that makes equals to 0. So previously was 0, right now is infinity. So previously if 0 you take the top. Now if it's infinity then you take the bottom. So in this case, in order to make, so therefore this has to be equals to 0, right? So 1 minus half omega square is equals to 0. 1 is equals to half omega square. And then if you were to rearrange, you get 2 equals to omega square. And then omega is equals to square root 2. Okay? So after which, once you get this, okay, this is a frequency that reflects so this is the frequency of where it's here. Okay, so if you were to check, okay, if you were to use this transfer function and then I put it into our, okay, this is exactly the one that I've shown you. I didn't cheat the filling. Okay, this is s plus 1, s plus 2. Okay, it will be s squared plus 3s plus 2. S squared plus 2s plus 3s plus 2. So it's over here. And then if I were to run the nyquist plot, okay, I will have this plot. And then if it's in terms of positive, okay, so therefore as you can see, when the real is actually 0, okay, is at this point, imaginary is this value. I haven't proved it yet. So, but however, the frequency is 1.42. Okay, 1.42 is actually square root 2. Okay, if you were to take a look, and then where's my square root? Where the hell is my square root? No, this is not square root. What the fuck? Hold on. There's a square root. 1.414. This 1.42 is about the same. So as you can see, you can use this method. So typically, as you can see, trigonometry is very important. And then after that, if you want to find the frequency, I mean you want to find the imaginary value, right? So typically you want to find it. So what you can do is you can actually sub in into your function. So let's say if you have square root 2, right? So it's pretty much straightforward now. So let's take this transfer function, okay? Before I separate it. Okay, you can also do that lah. Anyway, you can just use this one It's okay, no problem. Plus 1. Okay, and then I think just multiply in so it will be j square it'll be square root 2. So this is my omega equals to square root 2 j plus 2. Okay, so it's exactly the same thing over here. I just simply multiply because you want to use quadratic equation. So if I were to solve for it, what do I have? So it will be j times j is actually minus 1, so I have minus 1. Because square root 2 times square root 2 is actually 2, right? So yeah, minus 2. And then it will be what do we have? We have 2j square root 2 plus 2j. That means it will be 4j lah, okay? Because this is 3j lah, 3j. Because this times this is 2j square root 2 and then plus 1j square root 2. Okay, so 1 times this one is actually square root 2j lah. So because we have 2 times j square root 2j is, I think you get what I mean lah. So this 3j square root 2. Okay, plus what do we have? 1 times 2, 2. So end up you can see that 1 divided by minus 2 plus 3j square root 2 plus 2. As you can see, the real axis is 0. So what I can do now is actually to evaluate what is actually this value. Okay. So if I will do that, so just now as you know that square root 2, okay, if I square root 2 is 1.414, if I times 3 is 4.2426, right? So 1 divided by 4.2426, I have 0.2357. Okay, I have this value over here. Okay, so therefore if you were to check back, okay, if you check back this thing, you're actually 0.235. Okay, it's the same value, 0.235, 0.235. Okay, except it's negative in this case because this only helps you to define your magnitude of the so-called the complex number. Okay, so because if it's here or if it's, let's say, hold on, if it's here or if it's here, as you can see, it's about the same value. So you just know that it's flipping. So since we are finding this portion of it, you know it is negative already, so you can actually straight away find the value. Now on top of it, right, because we already specify that it's going in negative 90 degrees, so you know you're actually talking about this portion over here, right? Because as you know, we are actually setting up the equation using negative 90 degrees. So typically you know that it is in this region. So therefore you can actually straight away use that method to solve for things. Okay. So I hope that I prove to you in a in a pretty decent way. And then in the next video, perhaps I could use the second method. Okay, in this case, we assume that r equals to 0. Not assume, but rather we treat r equals to 0. And then we use the conjugate method to solve for this. Okay, so I'll see you in the next video to try to solve for that. Eventually, to solve for this frequency, okay, equals to square root 2. If I solve for this, you can just straight away sub in the transfer function, you can solve the answer. So so next video I'll just derive this one. Okay, and I'll see you there.